Three problems, 6, 11, and 16, but with a lot of steps. Problem 6 talks about gypsy moths, and it gives us 4 years, 1978, 1979, 1980, and 1981, and it gives us the acres. Part A says plot the number of acres Y against the year X. The pattern of growth appears exponential. So what they want you to do there is to clear out all your lists, put L1 and put the years in L1, put the acres in L2, and then and then you want to, second stat plot, turn plot 1 on, make sure it's L1 and L2, and zoom 9 to look at the graph and sketch that exponential graph onto your paper. In part B, want to verify that y is being multiplied by about 4 each year. So the first one that you do is 226,260 divided by 63,042. The next one that you need to do is 907,075 divided by the one above it, which is 226,260. Then the last one you need to do is 2,826,095 divided by the number above it, which is 907,075. Basically, you should make sure when you do that it's going up by about 3 or 4 each time. In part C, take the logarithm of each number y and plot the logarithms against the year x, and it should be linear. So what exponential functions say is, in part A we saw that there was an exponential graph. In part C we need to go to L3 on our calculator and highlight L3, and in L3 we just want to hit, we have to have L3 highlighted, but we just want to hit log of L2. So log and then parentheses L2, and it's going to take the log of your y's. Now once you do that, you want to graph the scatter plot. So a scatter plot now will be L1 and L3, and you want to zoom 9 to look at it, and it should be linear. So when we take the log of an exponential function, it should make it linear, and I want you to sketch those 4 dots. And then we do, in part D, it says verify that the regression line is log of y equals. And how you can verify that is you do stat calc number 8, and you want to do L1 and L3 again, because we're talking about the log of L2. So do L1 and L3, make sure you store it in Y1, and then you get an equation, and you should get that negative 1094.51 times 0.558x, or plus 0.558x is what you should get. So make sure your calculator gives you that. In part E, it says construct and interpret a residual plot for the log of y on year. To make a residual, we go all the way to L4 now, and we highlight L4, and we're going to do observed minus predicted. So we're going to do L3, because we're still looking at the logs, minus y1 parentheses L1, and I want you to write down those 4 residuals. Then I want you to do a residual plot, which is now L1 and L4. So go into your stat plot and do L1 and L4, and your residual plot should have 4 points on it and have a horizontal line above and below. Part F, the next part, says perform the inverse transformation. What the inverse transformation is, if you look on page 209, it shows you how to take a log equation and change it to the inverse. All it does is put 10 and you go to that power. That's how you change the equation to an inverse function. How we do it on our calculator is, if we already have the equation saved in y1, we go to y2 and we just type in 10 to the y1, and I think they actually show you how to do that on page 211, but go to y2 and type 10 to the y1. That's all you'll need to do. And then you will, when you graph, you go back to the original data, so back to the stat plot and do L1 and L2, hit zoom 9, and because we put 10 to the y1 and y2, it should actually show that line going through the points to prove that it's exponential, and you need to sketch that. G says use your model to predict. So once we've done all of this stuff, we want to actually predict in 1982 what's happening. You have to have 10 to the y1 and y2 to be able to predict. So we get a second table set, and we want to start our table at 1982, which is where we want to predict. And then we get a second table, and we want to look at the value in y2. And if it has an E there, you just highlight it, and you can see exactly what it is. But you want to highlight that value in y2, and that is the prediction for the number of acres in 1982. So a lot of stuff to do on that one, but that's how it works, and it should help you through these problems. All right, number 11. Number 11, we're talking about population and date. Your dates are going to go in L1 and your populations are going to go in L2. That's part A. Just sketch that after you put them in. Part B, in L3, you're going to do the same thing. So clear out your y equals stuff, clear out your y equals, clear out all your lists. Everything's got to be cleared out before you do a new one. And in L3, you're going to again do log of L2, and you're going to sketch that graph. Now what you should see in that graph is that you have a slope and then you have another slope. So it looks like it's split into two parts. And what it says is after 1880, the growth was actually at a slower rate. Now tell how you can tell that it was at a slower rate, and you can from that linear graph of L1 and L3. In part C, it says use all or part of the data to construct an exponential model. Now if we want to construct a model for 2010, we're only going to use the part closest to 2010. So what we're going to do is delete all the data from 1880 and before, and just use the part after. And when we predict, so after we delete all those, to predict, we need to again save our L1 and L3, do stat calc 8 L1 and L3, store it in Y1. Then in Y2, we're going to put 10 to the Y1, and then to predict, we're going to second table set, and we want to start at 2010, then go to second table, look for 2010, scroll over to Y2, and it should give you a number in the 300s, and you would know you're correct on that for your prediction. Part D, construct a residual plot. If you're doing a residual plot, you go to L4, and again you do L3 minus Y1 parentheses L1, and on your residual plot you go to stat plot L1 and L4. It also asks what your R squared value was. It was a very high number near 1, but remember stat calc 8 will give you that if you forgot to get it the first time. And then in E, comment on the quality of your model. Use your R and your R squared to comment on your quality of your model. Takes us to number 16. Problem number 16. If we flip a few pages, it talks about the price of pizzas. It gives you small, medium, large, and giant. It looks like the cost of them is going up by $2 each time, so we would think let's use a linear model, but since you know this is nonlinear, then we're going to use an exponential model here. So that's the model we're going to do in part A, is exponential. So to construct that, in L1 we're going to put the size 10, 12, 14, 18, and in L2 we're going to put the cost 4, 6, 8, 10. Comment on your model. So basically you kind of comment on the scatter plot if you think it looks exponential. Would you advise the manager to adjust the price on any of the pizzas? Well, we see that small, medium, and large goes up by $2, and then the giant goes up by 4 inches, but only $2, so maybe we would want to raise that price. You could say something about that. C, use your model to suggest a price for a new pizza. So for that one, what we're going to do is, again, go to L3 now after you put them in, and do the log of L2, then do stat calc 8, L1 and L3, store it in Y1. Okay, that's your model, so that's your equation. When you do stat calc 8, you do the log of y, you write your equation, log of y equals what it gives you. Then you're going to go to y equals, and your equation should be stored in Y1. In Y2, you're going to put 10 to the Y1. And then to predict, it asks you to predict the price for a new personal pizza that is 6 inches. So second table set, started at 6, and look at what your Y2 is for that. And then it asks you for a 24-inch pizza. So second table set, started at 24, and then go to second table and look for your Y2 and see what the price would be for a 24-inch pizza. Okay, so a lot of stuff to do on these. And it's only 3 problems, but it'll take you through a lot. If you don't understand it the first time, rewind through my video and go back and follow it step by step. If you follow it step by step, and if you look back in the book at what the equations look like and how they tell you to put the stuff in the calculator as well, it will make sense to you, and I think you can do this. This is just day 1, but remember, we have another day of a couple more problems and a quiz coming up Monday and a test on Tuesday, so you really got to get this information and make sure you store it away. Alright, thanks.